Welcome once again in the class of design of steel structure. So we are learning the compression members. So we have seen the design procedure. Today we are going to solve the problems based on the compression member. So I am Mr. Sogole, Assistant Professor, Civil Engineering Department. So we'll begin with the problem, that is an ISA 100 by 6 Fy equals 250 Newton per mm square is used as a strut in a truss. The length of the strut between the intersection at each end is 3 meters. So L is given, that is 3 meters. Calculate the strength of the strut if three cases are given over here. That is, it is connected by two rivets at each end. It is connected by one rivet at each end, and it is welded at each end. So from steel table, first we will see from the steel table, we will take the properties of this particular member. So this is the steel table. So we need 100 by 6 member, that is this 100 by 6. We have the area, that is area is 11.67 centimeter square. Then the radius of gyration, what we need, so find on the next page. So here 100 by 6. So the radius of gyration, that is we have 3.09, 3.91, these are in centimeters, and 1.95, that is 19.5 mm. So moving towards problem again. So the R minimum, that is RVV, that is 19.5 mm, and area is 11.67. So obviously area is in the centimeter, we are converting it into mm. So we are having the properties over here. So the first case, that is L equals to 3 meter from the table 5.2. So we have the table 5.2, that is from the IS code. According to this table, the single angle is connected with the more than one rivet or the weld, that is we are taking here, it is a 0.85 L and sigma C as it is. So the L effective is 0.85 into 3000, that is 3 meters. We are getting 2250 mm. So lambda here is 2250 divided by R minimum, that is 19.5. So that becomes the 130.769. So it should be lesser than 180. Again we have the condition, so it is there. So uh, hence it is okay. So now from the table 5.1 from IS 800, so we have the IS 800 over here, and now we are going to table number 5.1. So here we'll find the appropriate values, that is for this 130.769 and Fy equals to 250, 130.769. So for this 130 and for this particular 250, we are getting somewhere between 51 to 57. So what I have done, I have interpolated this thing. So 130 and 140, so 57 and 51. So what is the value for 130.769? So I have interpolated over here. So that value becomes 56.538 Newton per mm square. So the strength of the strut is 56.538 into the area, that is we got over here. So 1167. So the strength of the strut becomes 65.98 kilonewton. Now in second case, what is the second case? It is connected by one rivet only. So when it is connected by one rivet, so L equals to L effective. Only thing in that case, we have to allowable compressive stress will reduce up to zero point 0.8 into sigma AC, as you might see over here. So we have single angle connected with one rivet, length is equals to 1L, and it is allowable compressive stress reduced by zero point 0.8 into sigma AC. So whatever you are getting, you have to multiply it by zero point 0.8. So again, the L by R ratio, that is L is 3000 divided by 19.5, it is 153.846. Again, it is less than 180, hence okay. So from the table, that is, we have to find the value for 153. So again I am moving 153. So this is somewhere between this 45 to 41. So 45 to 41, I am interpolating it, so I am getting 43.46 value. So by reducing it up to 80%, we are getting 34.76 Newton per mm square. Then the strength of the strut is 34.76 into the area. So that becomes 40.564 kilonewton. And now the third case, that is for the welded at each end. So for the welded strut at each end, the specification of IS code are same as the case A, that is this case. So obviously the strength of the weld is also same, that is 65.98 kilonewton. Now the next problem, calculate the strength of discontinuous strut of the length 3.2 meter. The strut consists of two unequal angles, that is 100 into 75 by 8. Fy is given with long leg connected and placed. Two cases are there on the opposite side of the gusset plate and on the same side of the gusset plate. So accordingly we have done the figure over here. So this is ISA 175 by 8 and it is unequal connected with the long leg. This is on the opposite side and this is on the same side. So first from the steel table we need to find the properties for two ISA back to back and space 10 mm apart. So we have the direct provision in this particular steel table. Let me find. These are the channels back to back. Same way we have the angles back to back also. So these are the star like angle and this is the angle back to back. But now this is shorter legs back to back. Let me move upward. So again this is also shorter leg back to back. In our case the angles are connected with the longer leg. So this is the case of longer leg angle back to back. Our section is 175 by 8. So we have to find 175 by 8 over here. So this is 175. So here this is 175 by 8. We have the area of, this is the weight and this is the sectional area. So the area of 26.72. So area 26.72. Then we have to find Rx6 and Ryy for the same section. So let me, this is 31.4 Rxx, which is over here. And what is the Ryy for the same section? This is the Ryy, that is 31. Let me guess. It is not that is the center of gravity distance. So here the radius of gyration about y axis, we are having the 10 mm, this thing apart. So this thing, that is 32.2 is the Ryy for the same section. So it is 32.2. So amongst that R minimum is 31.4. So L, we are getting 0.85 L, because the conditions, it is the long leg connected. So L, so here long leg connected, and these are the double angle. So this is 0.85 L we are taking. So it is 0.85 into L, that is L effective. So that becomes 2720 mm. So L by R, that is this 2720 divided by 31.4. We are getting cylinder is a ratio of 86.62. So from table 5.1, again moving towards the table 5.1, we are having the value of 86.62. So 86.62. So this is between somewhere between this 101, this is this 101 and 90. So we are interpolating, that is 90 and 80, 86.2, 90 and 101. So by interpolating, we are getting this value 93.71. So the sigma AC is 93.71. So by multiplying it by the particular area, that is 26.72, what we have find over here. So this is 250.4 kilonewton. So this is the strength of the this first case. Now the second case. In second case, they are on the same side of the gusset plate. So Rxx and Ryy we are going to find. Now they are connected. Here you can see the shape. They are on the same side, so they are connected with now short leg. Earlier it was long leg, now they are connected with the short leg, and distance between them is 0. So while looking into the table, we have to now find the members are connected with the short leg now. So this is the case. So 175 by 8. The area remains same, that is this 26.72. Now the Rxx is 21.8. So this Rxx is 21.8, and again you can see over here the radii of gyration about y-axis in centimeter. So we are having this section 175. So when they are placed with this distance 0 0, that is back to back angles, so we are getting here 4.41 centimeter, that is 44.1. So here it is 44.1. so in between two r minimum is 21.8. so here L equals to L, because we have seen when these are on the same side like this, so the same side, the L equals to L. Only thing is we have to reduce this sigma AC. So L equals 12, that is 3.2. So dividing by radius of gyration, we are getting in 146.8. So from the table again 146.8. So it is somewhere between this 51 and 45. So 51 and 45. So we are getting here by interpolation, that is sigma AC 46.93. So the allowable working stress is 0.8 into sigma AC. So that becomes 37.54. So the strength of the strut is 37.54 into this area, that is 100.300 and 100.31. So this is the strength of the or load carrying capacity of the member. So the important thing in this are to finding the exact properties of the section as per our requirement. As you can see, we have seen the both cases, that is shorter legs back to back. So we must know when we need to see the shorter leg back to back, and we are getting the properties in the steel table itself. So for that, these things we know, that is radius of gyration about y-axis, and here it is about x axis. So all the properties has been given over here. Only thing we need to find those things. Again, we have referred this thing also. So when to take longer legs and when to take shorter legs, that is the important thing, and that we need to find accordingly. So all the properties has been given in this particular code. So this is for this lecture. That is, we have found the properties of the sections as well as the load carrying capacity of different cases of the struts. So for the reference, I have used the book of SK Duggal, Design of Steel Structure, and IS code, that is 800 1984 version, and the steel table. So this is all for today's lecture. Thank you.